Okay, students, let's continue with this packet and starting with this problem number 6 on rational function. Now, if you take a look at this problem, it looks pretty intimidating. Lots of fraction within the fraction and so on. But don't fear. Let's break this down a little bit more, and I'll show you how to solve this methodically. So here part A says simplify each of the two fractions as much as possible. And when they say two fractions, even though you see a lot, what they're really talking about is you got one fraction here, this is the first term, plus another fraction over here. So you want to simplify each of the two fractions as much as possible. So let's do that. So part A, in fact, part A, let's do it this way. Let's take the first fraction, which is x over 9 plus 1 over 3 plus 1 over x divided by x squared over 9 minus 3 over x. And you say, well, how in the world do I simplify this one? Well, the way you think about it is with the numerator, you got three fractions going on. Denominator, you have two fractions going on. And you look at the denominator, you got a 9 going on, you got a 3, you got an x, you got a 9 and an x. So all the common factors turns out to be 9x. And since this is a fraction, right, you have to think of it as a whole. You can't really do something to the top without doing the same thing on the bottom, because you can't inflate or deflate or mess with this fraction as a total value. You had to maintain its integrity, which then the only way you can do it is multiply by 1. But 1 can be something over something as long as they're the same. So I can think of it as multiplying by 9x on top and bottom. Think of it this way, right? So I can multiply 9x on top and bottom. So if you think about it, right, 9x times x over 9, 9x times x over 9, 9 cancel out, x times x gives you x squared. Now this is a fraction. Now 9x times 1/3, 3 and 9 reduced to 3. 3 times x is 3x. Okay. And then 1x times 9x, 1x times 9x, x and x cancel out, so you end up with just 9 right here. You see? You see that? And if you don't quite get it, think of it this way: is x over 9 times 9x plus 1/3 times 9x plus 1x times 9x. That's basically what's happening. Okay, so we're doing exactly the same thing on the bottom too, right? X squared over 9 times 9x minus 3 over x times 9x. So in this case, right, 9 and 9 cancel out. X didn't get canceled out, but x times x squared gives you x cubed on the bottom. And over here, x and x cancel out, so 9 times 3 gives you 27, so minus 27. So as you can see, this first term gets simplified already. Now, this is at least this is one term. This one basically is this portion right here. Now I want to simplify the next one now. Next one, this one. So I had to go over here. Now let's do it this way. 2 minus x over x squared minus 4. I need to simplify this. Okay. And what can I simplify? Well, what I notice is that on the bottom, this is a difference of square. So I can write this as x plus 2 times x minus 2. So that's not a problem. On the top, this is 2 minus x. Well, it's 2 minus x, but I can flip this and write it as negative x plus 2. But here's the problem is this is a negative x. The term on the bottom is all positive x's. So what I can do is I can factor out the negative 1 out here on the top. So I end up with x minus 2 on the as the remaining term like this. Now the advantage of that, me doing that is because now take a look at this. I end up with a term that I get to cancel. So I can cancel this term out. So then I end up with negative 1 over x plus 2. That becomes my second term. So you see, this one and this one is the same, and this one is the same. So I end up with two simplified terms. That's how you simplify. Alright, so that's part A. Part B then is you actually add them together. So part B is basically I'm trying to do this. F of x is equal to this term plus this term. So now I'm actually going to carry it out. Right? So I'm actually going to carry it out and see what's going on. So I will have f of x is equal to taking this term right here, x squared plus 3x plus 9 over x cubed minus 27, and I'll actually add it to negative 1 over x plus 2, or essentially subtract, right? Essentially subtract. But so you say, well, how do I then simplify this? All right, take a look at this. I noticed that this is x cubed minus 27. Now, here is where my memory of some of the binomial expansion is coming to help, right? And I know, not in this case, I notice this is a difference of cube. So notice, I remember this. I remember a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Okay? And so if that's the case, I notice that x cubed minus 27 essentially is x cubed minus 3 cubed. So what that means is that that means that a is x, b is 3, and I end up with the x squared plus 3x plus, now b is 3, so b squared is 9. So what that means is that f of x becomes, right, up here is x squared plus 3x plus 9. On the bottom, the x cubed minus 27, it becomes this expression, x minus 3, x squared plus 3x plus 9. And then this, bring this one down, minus 1 over x plus 2. Now notice, this term and this term cancel out. So this function gets simpler and simpler. F of x now becomes 1 over x minus 3 minus 1 over x plus 2. So wow, take a look at this. So much easier now. We went from this equation to this equation. They're exactly the same equation. Now, this is not even the simplest one, because we still have two terms over here, right? And we want to simplify, carry out the operation and make it into a singular term, right? So how do we do that? Well, f of x, we'll find common denominator, x minus 3 and 1 here, minus x plus 2 and 1 here. Now we can come up with a common denominator, x plus 2. But at the top we need to multiply x plus 2 as well. X minus 3. X minus 3. So continue on the bottom, x minus 3, x plus 2. On the top, x plus 2 minus x minus 3. So then all I need is go ahead and simplify this. I end up with x plus 2 minus x plus 3 on the bottom. I can multiply this out, x squared minus x minus 6, and finally it becomes 5 over x squared minus x minus 6. This is my f of x. Now, so if that's the case, then if one is to ask me about the domain, then it's very simple, right? I can say this denominator, we need to look for denominator when it cannot be 0. So you set it equal to 0. You solve for x squared minus x minus 6 equal to 0 using quadratic formula, and you'll be able to find the x's, x values where this function cannot exist. And now we'll give you a clue on how to write domain. So I'm not going to go over here, but just simply showing you how this one problem I can test you on just looking at this complicated equation. I will have tested you on how to find the common factors in a fractional fraction form, just like this. And I will test you on how to combine the fraction form of rational equations. And then I will test you, right? I can also test you on your knowledge of the binomial expansion or differences of cube, things like that. And then I will also test you ways in which you can, figure out how to solve fractional expressions like this. And then lastly, I can even go further and test you on whether you can decipher the domain of this rational functions. All right? Okay, now next problem. Now this function is a radical function. We have seen this before in one of the tests. So let's go for it. F of x is equal to x minus 3 square root of x plus 3. And here it says, what is the least value of x for which there is a real number value? Now, real number, here's basically asking you at what point you're going to get an imaginary number, right? An imaginary number is when you have a negative square root. So what that means is that you cannot, in this case, inside the square root, right, inside the x plus 4, this you have to figure out at what point x plus 4 will become negative. So this inside has to be, in order to be a real number, it has to be bigger or equal to 0. And if that's the case, right, then you know that x has to be bigger than or equal to negative 4. Okay, that's it. X has to be bigger than negative, because if you have something like, say, negative 5, which is less than negative 4, if you put negative 5 into here, you end up with square root of negative 1, which is imaginary number. Part B. First of all, suitable domain, right? Suitable domain. So the domain, you know that the domain has to be x bigger than or equal to negative 4. So you have negative 4 and, infinity. Now, so we can also use XY table to kind of support us in this process. And you can use your calculator. So I'm gonna speed up the process. You can test it out. So we know that if the domain is negative 4, let's start with negative 4 and put some value, negative 3, negative 2, 0, and then you can go to 5, right? A little positive number. You put it into the calculator, you should be able to get negative 4 here, negative 6 here, negative 6.24, I believe, and negative 6, negative 4, so on and so forth. So then if you graph it out, okay, you get negative 4 here, negative 4 here, 3, 2, 1, 0, 3, negative 2, and then say 5. So you're gonna have negative 4, and then go down to negative 6, and then even higher, 6 point something, back to 6, and then negative 4 right here. So I think your graph's gonna look like something like this. Okay. Now C says, what does the f of x intercept, commonly known as y-intercept, equal to? Now y-intercept is this point, right? This is the y-intercept. This is a y-intercept right here. And so when you have y-intercept, that is when you have when x is equal to 0. Y-intercept is when x is equal to 0. So that's easy, right? So f of x, so f of 0 is equal to 0 minus 3 times 0 plus 4, right? And so then you end up with negative 3 times 2, which is negative 6. So you end up with 0 and negative 6 as the y-intercept point, which is this point right here, right? Negative 6. Okay, part D says, what is the x-intercept equal to? Now, x-intercept is when f of x equal to 0. So we had to set the whole thing, set f of x equal to 0. So we f of x is equal to x minus 3, so the f of x is equal to x minus 3 square root of x plus 4. You want to set that equal to 0. So now look at this. This is just this equation. This is a radical equation, and we're solving for radical equation. So I'm gonna go ahead and put this term to the other side over here. So I end up with x is equal to positive 3 square root of x plus 4. Now then, what I'll do is, I want to get rid of the radical, so I need to put a parenthesis and square on both sides. So I end up with x squared is equal to 9 x plus 4. So I end up with x squared is equal to 9x plus 36. Move everything onto the one side, I end up with x squared minus 9x minus 36 is equal to 0. I can factor this, right? 1 and 1 for coefficient of 1 x squared. Negative 36, I can do 12 and 3, but because the cross term is negative, so I wanted the bigger number to be negative, so this times this, 3, negative 12, I'll end up with a negative 9. That's the cross term. So what that means is that I will have, I see 1 and negative 12, so it's x minus 12, and 1 and 3, so it's x plus 3 is equal to 0. If that's the case, then it's x minus 12 is equal to 0, x plus 3 is equal to 0, so that means x is equal to 12, or x is equal to negative 3. Now, if you notice, right, so then we got to check. We got to check. We got to check, right? So when x is equal to 12, let's put it into the f of x. F of 12 is equal to 12 minus 3 times 12 plus 4, so we end up with 12 minus 3 times square root of 16, which is 12 minus 3 times 4, which is 12 minus 12, equal to 0. Yes, that checked out. So x equal to 12 is the answer. Now what about when x is equal to negative 3? Well, we already did that, remember? F of x, f of negative 3, early on in our table, x equal to negative 3 is when y is equal to negative 6, which is not equal to 0. So x equal to negative 3 is an extraneous answer. So there you have it. Our answer for the zeros, right? The values, zeros, or the x-intercept is x equal to 12. Lastly, let me move over here so I can find space for it. Part E says find the two values of x for which f of x is equal to negative 6. Well, that means we take f of x, we set it equal to negative 6. So that means we take x minus 3 over square root of x plus 4, we set that equal to negative 6. Okay. Now, this is no different than, say, when we were solving this equation down here, like this, setting equal to 0. So we had to kind of think of it this way, is that maybe I can move the negative 6 onto this side and make the negative 3 square root of x plus 4 to the other side. So I'm going to do some movement over here. Okay. And if I do that, I can go ahead and square on both sides. And take a look at what happened. The first one, this one, x plus 6 squared, that's just x squared plus 12x plus 36. Okay? And on this side, this just becomes 9 times x plus 4. Right? Notice 3 squared is 9, and square root of x plus 4, it just becomes x plus 4. So it's 9 times x plus 4, which becomes 9x plus 36. Now notice that 36 and 36 on both sides we can cancel out. I can move the 9x onto this side. I end up with x squared plus 3x is equal to 0. That I can factor out x plus 3 is equal to 0, x is equal to 0, x is equal to -3. There you have it. Those are the two answers for part E. Okay? Alright, let's pause for now, and I'll see you in the next video.